Today in this tutorial, we will break down the workflow to understand how we can make a room makeover using AI to have different styles in the interior designing space. First, we will break down this workflow into three different parts in order to understand it much better. Namely, these three sections are text to image, IP adapter, and controller. The purpose of breaking down into three sections is that the three sections are responsible for separate functions, and they are doing separate functions. Like the text to image section is responsible for the generation of images based on our prompts, but in order to have the generation in certain style or theme, for example, here we are giving the Scandinavian style room, so IP adapter is responsible for extracting Scandinavian style from this reference image, and the next control net section is responsible for extracting the baseline data from the reference room image where makeover needs to be done. Let's go inside the text to image section, where we are having the first part is load checkpoint. So it is basically the noise detector model. Checkpoint we are using here is the Stable Diffusion 1.5 Juggernaut, which gives realistic images. So this is the predictor model, and it has three different parts, namely model, clip, and VA. The model is connected to the IP adapter, so we will going into that later. Then clip is connected to two clip encoders. So first one is positive and the second one is negative prompt. The third is VA. It is known as variational autoencoder, which converts images between pixel and the latent space. So all the generation part happens in the latent space. So it is responsible for sending the pixel into the latent space where the generation happens. So let's go inside the IP adapter section, where we will be focusing on IP adapter node. So IP adapter has three inputs. The first one is model, IP adapter, and image. So the model and the IP adapter inputs are connected to the IP adapter unified loader, whose input is the same as the output of the load checkpoint. So here the preset we are using light stable diffusion 1.5. So this works in this setup, and it's giving better results, and the outputs are connected to the input of IP adapter. The reference style image, here we are using Scandinavian styles, and the weak type is set to style transfer. So the output of the IP adapter is model, which is being connected to the input of the case sampler. Next, we will go inside the control net section. Here the main part is the apply control net node. Here four inputs are required. The first two positive negative are the output of the text encoding or prompts. These positive and negative prompts are being fed into the apply control net positive negative. The control net is the input of load control net model. This is the model. We are using MLSD Stable Diffusion 1.5 as our control net model. Image is the preprocessor. Here we are using MLSD lines as the precursor, which is responsible for extracting the state line data from this reference image. This is the reference image. We are trying to have the makeover of this room. So these are the parameters. Here we can see the preview image. These state lines are extracted from within that reference image. So in these parameters, the score showed we have adjusted 0.12. The low score in this means that implicate lines are being detected, and even the paint lines which are there, all data are being expected. The high score means that the higher we go, it means that only strong lines are detected, and these are being extracted. In this scenario, the floor has some lines which are being detected, so we have adjusted 0.12, so very less state lines from the floor being extracted. Next is distance threshold. So the smaller values will result in more segmented lines. and the larger values results in more continuous lines and stronger lines. So we have adjusted to 40. This is fed into the apply control net. Inside the apply control net node, the parameters of the strength are kept 0.7. We have adjusted by trial and experiment. The output of the apply control net are positive negative. These goes inside the key sampler positive negative. So the key sampler, the inputs are done. The last one is latent image. The latent image here will be providing an latent image, and we have adjusted the height and width according to the reference image dimension. And so here various parameters are given. So first one is C. This is the unique identification number product, and this is to be set as randomized. And the noise predictor model removes 35 times. These are the steps 35 works in this. And the CFG value is left as 8.0. And the lower value of CFG will result in more creative and less inclination to the prompt, and higher CFG value will result in more towards the prompted, strictly adheres to the prompt. So we have come up to 8.0. The sampler name, we are using DPM to MSD. Scheduler, we are using kept as normal, and the noise value is kept as 1.0. So the key sampler is the main part where all the inputs are being assembled, and the processing happens inside the key sampler in the latent space. So in order to have the output, we need to convert this from the latent space into the pixel space. So output of the key sampler is latent. It is connected to VA decode in order to pull from latent into the pixel space. So it is connected to the sample input, and the VA part comes from the load checkpoint VA. So VA decode output image is connected to save image. So here is the output of the Scandinavian style makeover of the reference image. So I hope you understand the working inside how this AI generation of interior design works. Thank you.